Okay, so we are solving now problem 8. So from chapter 6. So we have chapter 6, problem 8 from Halliday ninth edition. It's a long problem if you read it, like the text is long, but the problem is simple. What is it that they are telling us? Basically, that we have a rock, a big rock. The mass of this rock is given to us. The mass is 20 kilograms, and it's moving on the horizontal surface. Okay, it's moving at constant speed. Okay, so if it's moving at constant speed, the acceleration is 0. That's basically what this problem is saying. It's moving at constant speed, and we want to know, how is it possible? How is it moving? What is the force that is acting on this rock so that it can move in this direction at constant speed? Okay, taking into account that there is friction between this rock and the ground. What do they give us? That the coefficient of kinetic friction, because there is motion, so we are thinking about friction, but kinetic friction. So the coefficient of kinetic friction is 0.8. So given that, what is the magnitude of this force? That's all that the problem is asking us. How are we going to solve that? Well, what are the forces acting on this rock, in addition to the force that is making it move, right? Well, as we said, there is friction, and friction is against this motion. So let me draw it here. This is the friction force. Okay. In addition to that, well, if I think about the y direction, I have the weight of this object pointing down, and we are touching the ground, we have normal force. Very well, let me put the arrow here to remind us this is a vector. How do we find that force that is being exerted? Well, to find that force, I'm going to look at sum of all the forces in the x direction equals to m, a in the x direction. So I go, because I want to find f. According to the frame, I'm choosing a frame that is like this. To the right is positive, up is positive. So according to my frame, F is positive, so plus F. And according to my frame, the friction force is negative, so opposite, so minus friction force. This is all in the x direction. Now on the right side, we should put the acceleration, but I told you this object is moving at constant speed, so this is 0. Okay, so what is the force? What is the magnitude of the force? Equal to the friction force, the kinetic friction force. Okay, so my force is equal to the kinetic friction force. Okay, this sounds good. I know that friction force is me, that is given to me, 0.8. And I know that this is multiplied by the normal force. Oh, and there I am, I'm stuck. What is the value of this normal force? So to find the value of the normal force, I'm going to go to the same equation, but in the y direction. Sum of all the forces in the y is MAY. What do I have in the y direction? Well, I have normal, which is pointing up, is positive, so plus Fn, and we have minus mg, and that's all. This is 0. So I have the normal force, which is mg. I know the mass is 20, and I know g, and I put this here to get our force. And so our force, the force that is being applied, is equal to this friction force, the kinetic friction force is, and it's 1.6 10 to 2 newtons. So that's the end of this problem. You see, the text is long, but the problem is not hard, it's simple.